Let's continue our videos on circuits. This is video 4 on circuits, and we're going to continue with RC and just resistor circuits. Review from AP Physics 1 and RC circuits from AP Physics 2. So here is going to be our first question. It is still from Monterey Institute of Technology, and I will post, in the previous video, I posted links to the resources. And in this video, I will also add link in the description for the sources of these videos and practice questions. A battery with an EMF is connected to a load resistor R with a voltmeter V and ammeter A connected as shown. Before the switch is closed, the voltmeter indicates a potential of 9 volts across the battery. After the switch is closed, the voltmeter indicates a potential of 8.4 volts, and the ammeter indicates the current of 0.8 amps. What is the internal resistance of the battery? So I redrew the circuit, and in this circuit I have in blue is the battery, and it has internal resistance of the lowercase r and the EMF. So I can do the total voltage in the circuit is dropped and equals to 0 at the end. So I have EMF minus the current times the internal resistance and minus the current and times the resistor is equal to 0. That's after they connect the resistor, and before they connect the resistor I have EMF minus I times R and equals to 0. So I have these two equations, before and after. So they have, before the switch is closed, the voltmeter indicates a potential difference of 9 volt across the battery. So I have all the voltage dropped inside of the battery before it's connected. So I have the EMF equals to I times R and equals to 9 volt. And I do not know what the internal resistance of the battery is, so I'm looking for that internal resistance. And after the resistor is connected, I have EMF minus I times R, the internal resistance part, equals to IR and equals to 8.4 volt. So I times R is equal to 8.4 volt. That, and they give you what the current is, 0.8 amps. So I can find that R is equal to 8.4 divided by the current, which is 0.8, and that will give me the resistance of 10.5 ohm. And I can use these two equations. So what I know is EMF is 9 volt. So I have EMF minus I times R. So I have I times R and equals to 8.4. So I took it from this part. EMF is 9. So I have 9 minus the current is 0.8. Internal resistance and equals to 8.4. So R is going to be equal to 8.4 minus 9 gives you negative 0.6 divided by negative 0.8, which gives you 0.75 ohm. So internal resistance of the battery is 0.75 ohm. In this question number 12, and it's also from the same source from Monterey Institute of Technology, we have 3 capacitors are connected to a battery as shown and allowed to charge fully. What is the equivalent capacitance of 3 capacitors? When the capacitor is connected in parallel, we just add them. So you have 8, 20, and 40, that gives you 68. So you have 68 microfarad. For resistors, when they're connected in parallel, you do 1 over 1 over 1 over the result flip over. And for the capacitors, when they're connected in parallel, you just add them. For the resistors, when they're connected in series, you do the same addition, you just add them all together. And for the resistors, for the capacitors, when they're connected in series, you do 1 over the result flip over. So it's complete opposite of what you do for the resistors and the capacitors. So here you have parallel connection of the capacitors, so you just add their values, and that gives you 68 microfarad. For the next question, they have 3 resistors, 4, 3, and 6 ohm are connected to an 18-volt battery as shown in the circuit above. The net or overall resistance of the resistors is, so I see parallel connection. So for parallel connection of the resistors, I do 1 over the result flip over. So I do 1 over. The common denominator is 6. And so this total resistance is going to be 2 ohms. So it's 1 over the result flip over. And then I have 4 ohm resistor and 2 ohm resistor. The total resistance of the circuit is 6 ohm resistor, because I can rewrite it as 4 ohm resistor, then it is 2 ohm resistor, the one that I just calculated with 1 over the result flip over, this part. And then I have the battery of 18 volt. So your total resistance is 6, and they ask you the overall resistance is 6. If they ask you to calculate the current, you would have the total voltage, which is 18, divided by the total resistance, which is 6. So the current in this circuit would be 3 amps. That means leaving the positive side and coming to the negative side, the current is flowing in this direction, and it is 6 amps. If I measured the voltage on this resistor, it would be the current times the resistance, which is 12 volt. And if I measured the voltage on this resistor with the voltmeter, voltmeter always measures the resistance parallel to the resistor. So I have the current, which is 3, and the resistance, which is 2. So that gives me 6 volt. So that means between this point, I'm going to call it A, and this point B, the voltage is going to be 6 volt. So the voltage divided by the resistance will give you the current. So the total current here is 3 amps. So there's 3 amps passing through the first resistor. And then when it gets to the point A, they have to split. The current has to split. So I have 6 volt between A and B. So the voltage between A and B is 6 volt. That's the voltage between point A and B. And voltage divided by the resistance gives me the current. So the current here is going to be 1 amp. So through 6 ohm resistor, you have 1 amp. And the same voltage is here, 6 volt. But divided by 3 ohm resistor gives you 2 amps. So you have 3 amps. Sometimes in the classroom, I tell the students it's like aliens. 3 aliens are running. They run through this resistor. They come over here and they have to split. And when they split, one went through the 6 ohm resistor, and 2 amps will go through the 3 ohm resistor. Then they're gonna unite, and again 3 amps will be running back to the battery. If you had to calculate the power on each resistor, it's the same as the brightness on each resistor. So let me call this one R1, this one is R2, and this one is R3. So the power is equal to IV, or I squared R, or V squared over R. So I have I and I have R for the first resistor, for R1. So if I calculate the power on the first resistor, I have I squared, which is 3 squared, times the resistance, which is 4, So 9 times 4 is going to give me 36 watts. If I calculate the power on the second resistor, I can do the same. I squared, which is 1 squared, times the resistance, which is 6. That gives me 6 watts. And if I calculate the power on the third resistor, it is the I squared, which is 2 squared, times the resistance, which is 3. So that gives me 12 watts. And if every single one of these resistors was a bulb, so the bulb on the circuit would look like this. So if I had a light bulb, and then if I had another light bulb, and another light bulb, and all of that connected to the battery, then the brightest would be the first one because its power is 36 watts. The next one is going to be, for the brightness, is this one because it would be 12 watts. And then the last and least, or the least brightest, would be the second resistor or the second bulb, which is 6 watts. Here's another question that we're going to look at, and in this question, no capacitors, just the resistors, and a battery of voltage V or 2V and resistors of resistance R or 2R are connected in various combinations as shown below. In which circuit is the most power dissipated? So I'm going to write the power formula again. Power is equal to I times R, I times V, and equals to I squared R, or V squared over R. The one that you will see on AP exam is only this formula, so you have to just use V equals to IR, Ohm's law, to do the calculations, to derive the formulas for the rest of them. So here I have the power on the first one is V squared over R. The power on the second one, I need to calculate the total resistance. So for the total resistance, I have 1 over 2R, they're parallel, plus 1 over 2R. So it's 1 over plus 1 over, and that gives me 2 over 2R. The result flip over is going to be R. So the resistance of the circuit, the total resistance of the circuit, is just R. So the same power in this case is going to be V squared over the total resistance, which is R. So we have the first one, the second one. For the third one, the total resistance in this case is 3R. So the power is equal to V squared over 3R. And for the fourth one, I have the power is equal to, the total resistance is 1 over R plus 1 over R. That's 2 over R, and the total resistance is going to be R over 2. So I can replace these two resistors with one resistor, which is R over 2. So you have the power is equal to V squared over R over 2, which gives me 2 times V squared over R. So far this one is having the largest power dissipated. So that could be an answer. And in this case, your total resistance is 3R, and the power is equal to V squared, which is 4V squared divided by 3R. So in this case, I have 4/3 V squared over R. So two largest ones, so this one, this power is exactly the same as this power. Then this power is the smallest. This one is 1.33 of the ones that is the first one, and this one is twice as big as the first ones, or the first two ones. So they ask you in which circuit the most power dissipated. So the answer would be in D. It's twice of the first two, and it is still larger than the last one. For the next question, again, they give you different circuits, and let's see what the question is. A battery of V or 2V and resistors of R or 2R are connected in various combinations as shown above, which two circuits have an equivalent current flowing through from the battery? So let's calculate the current through each circuit. So the current in the first circuit is equal to V over R, Ohm's law. The current through this one is equal to V, and earlier we calculated that the total resistance is R. So these two guys have the same current flowing through the battery. So through the battery I have I, so that's the current. Through the battery I have I, and then it's going to split. But they ask you how much current goes through the battery, so that is the same I. For this one is, for the third one, I have I, so I'm talking about this I, is equal to V divided by the total resistance, which is 3R. In the fourth one, I have I is equal to the voltage divided by the total resistance, which is R over 2. So in this case, the current is equal to 2 times V over R. So far the largest current. And for the last one, I have the current is equal to 2V over 3R, the total resistance. And I'm gonna stop there. So the question was, which two circuits have equivalent current flowing through them? And it looks like it is 1 and 2. So the answer in this question is gonna be 1 and 2. So I mentioned in a few questions in these AP Physics 2 questions about the resistors, and we did it a lot in AP Physics 1, but I'm just going to go over it one more time. So if you have circuits resistors connected in parallel, they all share the same voltage. So they will have the same voltage. And so here I have the same voltage because they're connected to the same part of the battery. And the current, so when the current is going to be flowing, it's going to be from positive to negative. Positive is the longer one, so it's going to go this way. Now it has to split, so it will go through this resistor, and some of it is going to go through this resistor. So the current is going to be the largest leaving from the battery, and then it's going to split into the resistors. So the total current, I'm going to call this current I, is going to be the current through the first one plus the current of the second one. So that's the one that you see in the formula. So the current is splitting, and the current that is leaving the battery is equal to the current through one of the resistors, and the second resistor as many resistors as you have in parallel. And if you calculate the total resistance of the parallel connection of resistors, you have 1 over the result flip over. Then if you have them connected in series, then the voltage dropped on this resistor plus the voltage dropped on this resistor. So this voltage plus this voltage should give you the voltage of the battery. So the voltage of the battery is equal to the voltage dropped on every single resistor. The current is going to be the same through all of them, because when the current is floating, it's going to be the same exact current floating through this resistor as the one that is floating through this resistor. So they share the same current. And if you want to calculate the total resistance, you just add their resistances. So you just add the resistors, and that gives you the total resistance of the circuit. And also I mentioned before the Ohm's law, where V is equal to I times R. And I'm gonna stop this video at this point. There's gonna be more practice in the future in video 5 and 6 and maybe 7. And thank you for watching this video, and I'll see you in the next one.